So in this video we're just going to do a quick rundown on the basic rules of inequalities. Now you would have met them in primary school, you would have used them the whole way through secondary school as well. Sometimes they can be tricky, but most of the time they're okay, except when algebra becomes involved, because at that stage you will need to know certain rules for it to work properly. So I'm just going to run through that. So obviously the first one is greater than or equal to, less than, or less than or equal to. Obviously as we read left to right, the bigger one is, if the bigger one is on the left, it's greater than. If the smaller one is on the left, it's less than. Simple enough. Now this one here, less than or equal to, that means you could have a number. So I say if I pick the number 4, 4 is less than or equal to 10. So it could be less than it, it could be equal to it. 4 is also less than or equal to 4. It might sound a bit confusing. If it has both words, less than or equal to, then both options apply. 4 is less than 10. 4 is equal to 4. So you could say 4 is less than or equal to 4. So it is true for both cases. Okay, now, so just one or two of the basic rules at the end. So we have 5 is greater than 3 and 5 is greater than 3 on both sides. Now what I'm going to do for this left hand side is I'm going to add a random number. We'll add 4 to both sides and see what happens. So 5 plus 4 is 9, 3 plus 4 is 7. That's still true. So the inequality is the same. It's still greater than on both sides. If I go over here and we'll take away a random number, we'll say take away 2 from both sides. Then that gives us 3 and 1. That still works. Okay, so if you add or subtract any number, the sign doesn't change. Add or subtract, sign doesn't change. Because 9 is obviously still greater than 7 and 3 is obviously still greater than 1. Now another example, I'll use 5 and 3 again, same as above, but on the next one I'm going to use the less than symbol as well, so 6 is less than 10. And this time I'm going to multiply by a number, so we'll say 5 multiplied by 2, for example, on both sides. 5 by 2 is 10, is greater than 6, 3 by 2 is 6, 10 is greater than 6, so that still works, the sign doesn't change there. Similarly with this one, if I pick another multiplication, we'll say multiply by 3 on both sides. 6 3s is 18, 10 by 3 is 30, so 18 is less than 30, and on this side 10 is greater than 6. So when you multiply, I'll write it there in a different colour, when you multiply by, now what do these numbers have in common? They're both positive, so this rule applies when you're positive. So multiply by positive, signs don't change. So just for the both of those, if you add or subtract, it doesn't matter, the sign doesn't change. And at the bottom here, if you multiply by a positive, the signs doesn't change either, signs don't change either. Now when you multiply by a negative, that's slightly different. And similarly, because with these first two here, we multiplied by 3. If I want to go the other direction, and I want to go from 10 and 6 down to 5 and 3, or 18 and 30 down to 6 and 10, that's the same as dividing by 2 on this side, and dividing by 3 on this side. So if you multiply by a positive, the signs don't change. It's also the same if you divide by positive. There's no change. So add or subtract, there's no change. Multiply or divide by a positive, there's no change. Now in the next part I'm going to show what happens when you multiply or divide by a negative. So now here we have dividing or multiplying by a negative. I have a number line plotted out here, and I have a basic enough inequality. 2 is less than 4. So what I'm going to do is put both of those points on the number line. And basically when you're looking at the number line, if a number is to the left of a certain number, it's smaller than it. If it's to the right of a number, it's bigger than it. So you can see here clearly that 2 is to the left of 4, so 2 is smaller. If I pick the number 8, 8 is to the right of 4, so it's bigger. So that's basic enough. It's kind of common sense. But now, what happens if I multiply both sides by a negative? So what I'm going to do is multiply both sides by -2 and see what happens. So that then becomes 2 by -2 is -4, and -2 by 4 is -8. Now, if we plot these new points on the number line, we have a slight change. So now, the number that was on the left, which was smaller, is still on the left, but now it's actually bigger, because -4 is to the right of -8, so -4 is bigger. So when you multiply by a negative number, these signs flip over. Okay, so that 2 was less than 4, that was okay. But when I multiply both sides by -2, 2 went to -4, and 4 went to -8, but now this number is smaller than this one. So the sign has actually flipped over, gone the other way. So instead of saying 2 is less than 4, we now say -4 is greater than -8. Now for the second example, to do with division, I'm going to use the numbers 8 and 6. And instead of multiplying by -2 up here, down in this part, I'm going to divide by -2. And the same on this side, divide by -2. So originally 8 is this point up here. I'll put an X above it just so you can see the difference. And 6 is here. Now 8 divided by -2 becomes -4. 6 divided by -2 becomes -3. Now if we plot those 2 points on the number line, -4 is here, -3 is here. So going by that, we can see that -4 is now smaller than -3. But down here, 8 was bigger than 6. So our sign, it goes from greater than to less than. Okay, so if we were to recap on all of the bits and pieces, if you add or subtract, the sign doesn't change. The middle inequality doesn't change. If you multiply or divide by a positive, the sign doesn't change again. But in this case, if you multiply or divide by a negative, the inequality changes. That's the important bit. Or if you want, you could say flips over. Now in the next video, I'm just going to do a couple more examples that involve algebra, and we'll work out bits and pieces from there.